Hi guys. Welcome to the fourth session on the web dev demo classes. What we'll do today is we're gonna cover something really interesting. I would be showing you how to Google search things and how to read documentation well. So I'm actually picking up a topic which I don't use on a daily basis a lot. In the last few demo classes, I have shown you some topics which have been um, like basic front-end development, back-end and JavaScript, and also that's something that I very basic stuff, and I know and I use it on a daily basis. So it might have felt to a lot of you guys like I'm just writing. I have memorized things and I'm just writing whatever I want to write. Okay, so that's not how it happens. So like even very experienced developers, people who have worked on a particular platform for a long time also would very often be they'll be um, going up and doing some searches on Google, or they will be looking up documentation. And how do they do that? So for that, in fact, I have picked up a topic. I want to teach you guys a little bit about how to use Canvas, which is to draw things on the screen. And just a second. Yep. So what I want to show you guys is about using the canvas in the browsers, by which we can draw things on the screen. We can make something like a whiteboard, or we can make a game. So usually most 2D games that you see created using HTML, they are all using the Canvas API. So we'll be seeing how the Canvas API can be used. And interestingly, Canvas API is something that I personally do not have a lot of experience with. I have not made too many projects with Canvas, and on a daily basis I don't work with Canvas, right? So live today on this session, I will be actually Google searching stuff. I will be looking up documentation, and things will go wrong, and I will debug, and I will show that to you. Learning this is the most important thing, I believe, when you are learning anything web development, or Android, machine learning, anything for that matter. Learning how to learn new things is very important. So here's the demo for class, and I'll just for anybody who is here for the first time, so all of your code that I do during the class is visible in this repository, coding blocks archives slash full stack node.js demo. And I'm just going to be giving that to the chat as well. So the link to this. And today is the demo number 4 class that we are going to be doing today, right? And so what we'll work on is the HTML Canvas API. And let's just say, how do you go about, like, first time you're working on the Canvas, you've heard like with the Canvas, you can draw stuff on the screen. So let's just go to, Google. And if we just search on, Google itself, like, that's a very broad term, though. I think just searching how to use HTML Canvas, if you search that, so there is like a tutorial on W3 Schools. There is a tutorial on MDN, and there are a lot of places where. So I'm just going to go where documentation. I'm not going to force go and play some videos or something. What we have to do is we will be creating a Canvas element on our web page, and then inside that we will draw lines and everything. Okay. And so this is W3 Schools is a good place to quickly look up how things happen. And I generally tell this to my classroom course students as well, is that like when you're going for your examinations in college and all, you have the Indian author book, and you have this foreign author book. And the Indian author book is what you study if you have to study that particular topic in one day. And the foreign author book is what you study if you actually want to study that topic, and you have 1 month time, right? So pretty similar to that. I think W3 Schools is much like your Indian author book. And and this MDN tutorial is more like your foreign author book. It goes into depth, but you might feel a little lost initially because there is so much content and overly too much technical. So the W3 Schools content is more like, write this code and it works. And um, uh, MDN one is like, here is everything about Canvas, figure out how to use it, right? There's like a tutorial on basic shapes, applying styles and colors and all of that stuff. But like, if I want to quickly go down to how to build things using this, so let's check that out. So we have to create a canvas. You have to give it an ID, and let's start with that. So I'll create HTML5 page, and I will create say I'll just give an h1 tag and say that canvas demo, and we'll create a canvas. And this canvas, let's give it an ID. So the ID of this canvas is say I can call it paint box. Okay. And we can give this canvas some styling as well. So let's say we have a style.css file, and if we need some JavaScript, so we'll have a script.js file. Let's include both of these. We'll have the CSS for the style.css. We'll include the script for the script.js file, right? And we'll async and defer this thing. Cool. So guys, why are you joining so late? I think if you guys are just joining right now as well, please be in time to the class. Let's say we have this paint box. This is my canvas. Let's give it a height of say 500 pixels and a width of also 500 pixels. Okay, let's give it a border. Let's say solid black 1 pixel, like that. Okay, so you can have a dotted border also, maybe. Let's say have a dotted border, black 1 pixel, and let's run this program, and let's see. So this is my canvas demo. This is the canvas inside which we will be painting stuff, right? Let's do is, so what all stuff do we want to write inside the canvas? So we have to get access to the canvas. So let canvas equal to, or let paint box equal to document dot get element by ID paint box. And how to work with the canvas is as it is shown here. We do get element by ID canvas, and then we do ctx dot get context 2D, and then we start working on it. So here's the difference between reading up things on W3 Schools and say on MDN is that here it tells you that you do get context 2D. You might have this question in your mind, why 2D? Can it be 3D? What does context mean? So if you study from say something like MDN instead, let's say a basic usage, it shows how to do it. And so this is the canvas element, tells you in detail a lot about the canvas element. Okay. So there is a note here, and we will actually face this error. Some of you guys might, that if you face problems with setting the height and width, so don't set it in CSS, use it on the element itself. If you have such a problem, we will see it, okay? Then so we need a rendering context. So the canvas creates a rendering context using which, so there is a get context method, and it tells that we can either use 2D context to use two-dimensional rendering, or we can use WebGL context to render things in 3D. Now, rendering things in 3D is something I have very little experience with, so I will be showing you guys actually about 2D rendering only, how to create two-dimensional things just to begin with. And we would do is do get context 2D. So the difference in the approach here. So we just want to get things quickly done. I think my personal approach is usually I pick up tutorials or websites like W3 Schools and get started with it, be able to draw a line, draw a circle, and then try to understand, okay, what other context can there be, what other ways can I draw a line, and so on and so forth, right? So if I just do that, if I do let my context equal to so a lot of people call it as pen as well, because this is what you use to draw, and a lot of people write that paintbox dot get context and 2D, right? So a lot of people call it pen as well, because we use this context for writing, but you can call it context, you can call it pen, it's up to you. Okay, let's say I just call it context. So what we do with the context is context dot and here's the thing. In fact, let's do something. Let's not write it here. Let's go to our page and see what all things we can do with it. If I go to my console, so this is the context, right? So context dot, there is a option to call fill rect, for example, fill rect. And what does this fill rect function take? So what all things exist inside a context? So canvas rendering context 2D is the object of context type. And you can draw rectangles using clear rect, fill rect, stroke rect. Then there is text drawing, line drawing, and textiles, and fill and stroke styles, all of that, right? So let's say if we want to create a fill rect, and this fill rect function, here's the definition of the fill rect function. Right. So what does this fill rect function do? It takes x, y, width, and height. So if I want to create a rectangle at, say, the point 50, 50 of width 10 and height 10, right? And if I call that, so that gets drawn. As you can see, there's a little bit of problem. This 10/10, it should have made a square box, but it is not really a square box right now, as you can see. Okay, so things are a little stretched across or something like that. So what let's do is, if I set the height and width on the canvas itself, like I set the height equal to 500 and the width equal to 500 on the canvas element itself. In that case, if I run this, sorry, much better. It's actually a square is coming up, okay, as you can see. So so we have drawn a 10 pixel cross 10 pixel box. Now, if I draw a a 10 pixel cross 10 pixel box at 0,0, how does it get drawn? Okay, so that's how it gets drawn. So the point which I provide here acts as the top left corner, and this is the high width and this is the height. So that's what it says. Fill draws a rectangle whose starting point is at x, y, and whose size is specified by width and height. Okay, so this way we can draw a rectangle. Okay, we can draw. I have drawn a square for it. You can draw circles as well. So how can you draw a circle? You do context dot begin path context dot arc like this, and you can create basically a circular arc, finish it off, or you can draw text. So there are a lot of things you can draw. You can draw linear gradient, you can draw circular gradient. So there are many methods that exist. Okay. So what we'll do is, let's try to make, say, something of a game here on the context, right? And let's say how we can draw some rectangles with different sizes as well. So let's go about doing this. I will write a lot of my script in my JS, and we'll create a little game here. So let I will do is Let's draw, one, I don't know, annotation if it's available on my screen. Never mind. So what I will do is I'll be creating let me just go to my page and show you guys. So I will create, so I can do context dot clear rect from 0, to 500, and this will clear all the elements on my page starting from 00 to 500. It will clear the entire rectangle. So let's say I'll do context dot draw fill. I'll do a fill rect, and this. So you can change the fill style and fill stuff as well. So you can change the fill style to red, for example. And if I do fill style equal to red like this, and then I do context dot fill rect, I'll draw a rect at 0, 200, let's just say, and of size say 50, 50. That's the size. Okay. So we have this box here that I have drawn here on the screen, and then we will create a few more boxes here. Say context dot fill style equal to blue, and we will do context dot fill rect, and I'm going to draw one at say 100, 0, 50, 50. So I'll draw one there. Okay, and I will draw another one here. Okay, so what we'll do is we need to take this box in this game from the left hand side of the screen to the right hand side of the screen, and we can actually make something like that. So context dot stroke, let's say, so stroke style, and let's say let me draw another rect here of size say we had drawn the first one 0 to 100. Okay, so I'll draw one near the other side end. So I'll draw it at 450 and 200, and I will draw it a little bigger. So let's draw it at say 60/60, 440. Okay, and here context dot stroke. Okay, so what I have to do is I will have to take this box and bring it into this box here on the from the left side to the right hand side. And while I will be doing that, I want these boxes to be moving up and down. So that's the challenge. So these boxes will be moving up and down. And while they move up and down, I will have to move this box from left to right, avoiding them. And if I reach there, I will win the game. But if I collide, then I will lose the game. Okay, so that's something that we want to build here. Okay. So how do we go about doing that? Of course, so first of all, these lines of code that I have written, so let's actually represent these in form of some JavaScript objects. Okay, and what we'll do is we can create some classes. So we can create a class box, and this class box has a constructor. So this is the syntax of creating classes in JavaScript. Which again, in the actual course, we do it in depth. We do how classes are there, how objects can be created. It's very different from how it happens in Java and in C++. But so this constructor, and when we create a box, we need, a size, and we need a, so let's just say when we create a box, we need a size and a color. Okay, and we write like this dot size equal to size, and this dot color equal to color, and that's my box class. So if I have something like this, I can create boxes using this syntax in my code. let b1 equal to new box, and in box I will pass the size. The size of the box is say 40, and the color of the box is say red. So that's b1 is a box with size 40 and color red, like that. Okay. So I will also create is class player extends box, and which has a constructor with nothing at all. And let's say I will just do call super with so the player's box is going to be of 50 size and of say blue color, and class enemy okay extends box, and this is going to be a box with size say 50 and red color. Okay. Sense. So what we'll do is we will do is let player equal to new player, and so let e1 equal to new enemy, and let e2 equal to new enemy. Okay. Now what these boxes should have, they should have a initial location as well. So we do this is so this dot location we can actually do this dot x, and this dot y equal to 0, and this dot this equal to 0 as well. But the initial locations that we want for the player box is something a little different. We want the player box to be initially at this dot x at 0, this dot y at, so the x and y coordinates are, this is the x axis, this is the y axis, this point here is the 0, 0 point, and going rightwards is positive x direction, going towards bottom is positive y direction. Okay, that's how the axis in the canvas works. So we want the player to be at point 0 on x, and on y we want it to be at say exactly at the center. So if we want it to be exactly at the center, we would want it to be at 4 sorry. So I want this dot y to be at say in the middle of the screen around 250. So I'll put it at 225 so that it becomes the center like that. The enemy boxes, I want them both at this dot, so we can just change it afterwards as well also. So E1 and E2, what we can do is let E1 dot y equal to sorry, e1 dot x equal to say 120, and e2 dot x equal to 240, like this. Okay, now we can create as a function draw box, which takes a box as an argument, assuming, and what it will do is it will take the context dot fill style, and it will set to box dot color. Okay, and then it will draw a box context dot fill rect. It would do at box dot x comma box dot y, and of box dot size and box dot size. Okay, so we have this function called drawbox, and inside which if we pass a box, it will basically do this. It will draw the box with this particular color and this particular fields rect, and we can actually see that happen. So drawbox player gets drawn, right? So then drawbox E1, first enemy gets drawn. Drawbox E2, second enemy gets drawn, like that. Okay, so that's how you can easily divide your code into classes and functions properly. So your box class, players and enemies extend from the box, and we can create a drawbox function to draw every box. Okay. So what else would we have is that these boxes should they have an X and Y and all of that stuff as well, right? So now if I want that this boxes to go up and down, right? So in these enemies, let's say we provide them a couple of things, like we can, in the constructor, let's provide a speed, and we'll write this dot speed equal to speed. Okay, and what we'll do is we will use that speed to move the enemy box, say, up and down on my page, right? So how do we do up and down motion with the enemy box on my page? We need a function that runs in a certain interval. Okay, and to run a function at a certain interval, there are a lot of ways available. One of them I'll just show you is like this. We can run set interval, and set interval does is it takes a function here. The first argument it takes is a function, and the second argument it takes is the value of interval, how frequently you want it to run. So 100 milliseconds if I pass, and every 100 millisecond what I want to do is I want to clear the rectangle. So context dot clear rect 0 0 500 500. Okay, and then what I want to do is I want to do e1 dot y plus equal to e1 dot speed, and I want to do the same thing with e2. So e2 dot y plus equal to e2 dot speed. Okay, so after doing that, what I want to do is I will do drawbox E1 and drawbox E2. Okay. So, and this interval, if it starts running, if I refresh my page, and let's run it every 1 second, let's say. We need to set the speed when we're creating enemies. So let's say the speed of this enemy is 10 and the speed of this enemy is 20. Okay. And if we do that, you see every 1 second this is happening. And if I use a higher frequency, of course, you don't want, frequency like you can use any kind of frequency like set interval. You can set it at 100 milliseconds, you can set it a faster function as well, in which case, they will become like this. Okay. So that's how you can move those boxes, but they leave the screen after a certain point. Okay. And also the animation is not very smooth. Okay. So how can we make the animation smoother than that? Okay. So let's try to see. I mean, I know the answer, but let me try to find that out on Google. Okay. So how do we do canvas smooth animation? So let's see, we got a Stack Overflow answer out there. Okay, the Stack Overflow answer says that how to do this. So they have used something called WebKit request animation frame, and I think there is something we can do like that. And there is another answer which says about request animation frame like that. Let's check another answer as well. what other people are saying, and everybody is talking about this request animation frame thing. Okay, now request animation frame is what is request animation frame, and people are talking about it. So most people have given this answer like this. So let's read about request animation frame before immediately starting to use it. And what does request animation frame do in the web API? So the window.request animation frame method tells the browser that you wish to perform an animation, and requires the browser calls the specified function to update an animation before the next reprint. Okay. So this method basically helps you update your things inside your browser, right, before the browser will paint the screen again. Okay, now using this function has a benefit over doing set interval, is that your browser could be running at different frames per second FPS at different points of time. Maybe if the page is really heavy and there's a lot of stuff to load and a lot of code to run, your pages might not be running at 60 FPS right now. It could be running at a little slower speed right now. Okay, so whatever is that case, of request animation frame, right? So what will happen is that you can just call window.request animation frame, and whatever is the best possible frames per second that your browser has available, it will update the callback function at that particular speed. Okay, so instead of doing set interval like this, what we can do is we can do window.request animation frame, and here we can pass a function other than that, and we can do like this. Okay, now if I do it like this, what will happen on my page is that so this callback method is so this will happen only once rather than happening multiple times. Okay, so with set interval, what happens is that it keeps on repeating. With this method, it just happens only once. Okay, and it has happened once, as you can see. If it had not happened a single time, then the boxes would have been at the top of the screen, but it has been called once, but it does not get called again. We can do is something else. We can have a function called update. Okay, which does is call window.request animation frame, and inside that does the things here, and at the end of this function we just call update game again. Okay, and let's reduce the speed of it. Let's reduce the speed to 1 and 2, for example. Oh, sorry, we'll just call update game after the request animation frame has ended. Okay, so something is not working out here. Okay, the way we have done it. So how do you go about debugging this? Why is it not working? So a lot of times when I'm teaching classes, I've seen people just having written code till here, gone here, and Arnav Bhaiya, code chal nahi raha. And who says chal nahi raha? Think somebody who does not know web development, they open a website and they see the website is not running, and they're like, nahi chal raha website, so we will not use the website. Okay, but we want to be software developers. We don't want to be just users, right? So we should have a better answer and a better question in our mind than is it working or is it not working. We need to ask why is it not working, and we need to be able to find out why is it not working. That's the most important part. So let's start trying to find out why it's not working. Okay, and in fact I'm actually really stuck doing this problem. I'm going to be debugging live. I think I've made some mistake here, but let's find out what the problem is. So, if I just think that, how many times window.requestAnimationFrame is getting called. So console.log, if I do, frame update like this, and let's see, does this get printed? It does not get printed. So somehow it is not running. Now, anybody on the chat want to tell what's the problem? Can you see what's the problem? Why is this line not getting printed? Right? If it was outside this thing earlier, it was getting, updated, and so one update was coming. It was getting updated once, but not multiple times as it was happening earlier. Like when this entire thing was inside set interval thing, so earlier it was in a set interval like this, and we had called it like this, and we'd given it a 100 millisecond update. And you can see the frame update was happening, and you can see this number, it's increasing, the number of times the frame request is happening. Okay, so why so? So somebody has asked on chat. Yeah. So Mancha Lamba has the correct answer. Invoke nahi ho raha tha upar wala function, which is the correct answer. That is, this function I had not actually called. So let's just fix it again. So by the way, if I do it this way, let's see the performance impact of this also as well. If I go to performance impact and reload the page and start recording performance, and you can see it's pretty much fine. If I do set interval at 100 milliseconds, I get like 58 FPS is the speed that I'm getting. And if I see what's happening every 50 milliseconds, every few milliseconds set interval is running. If I reduce this to 10 milliseconds, much faster updates, right? And in that case, what's the performance chart for that? See, we are getting down to around 50 FPS. We were going down to 30 FPS in some places as well. That's the kind of performance. You should always know what kind of performance impact you are giving to your website as well with the kind of code you're writing. Okay, getting back to yes, debugging, good answer. What had happened is that we had not called it again. So function update game, inside that we will call window.requestAnimationFrame, inside which we will do our stuff, which is this. And at the end of it, we will call update game again. Okay. Now, let's see, does that work? We have to call this function, which we had forgotten, update game. We call it. Once we call it, and now it's working. Okay. As you can see, the animation is pretty smooth. It's not jerky. It's not 10 milliseconds. But let's record the performance for this as well. As you can see, we are able to stay at around 59 FPS. We are able to stay at 60 FPS if we use request animation update rather than using set interval. Set interval is a good tool to have, but not useful everywhere. If you want to set up a timer at an interval of every 1 second or at an interval every 5 seconds, set interval is good. But if you want actually animation updates on your screen, then you need to do this. You need to use RequestanimationFrame, and with that we are able to get these things moving. Okay, cool. Clear till now. So let's do a few more things. Instead of doing this manually, we will have a function called move. So we will have a function called move here. Okay, and I think we just write it like this. Sorry. So when you create a class, then functions don't need the function keyword. You just write it like this. And what this move function will do, it will do this dot y plus equal to this dot speed, right? So we will do e1 dot move and e2 dot move, okay? Which is fine. Now in this move function, we will handle the case of bouncing back from the walls. Okay, how do we bounce back from the walls? We will write that code also here. So inside the move function, we will do that if this dot y plus this dot size greater than 500. So this dot y is the point of the top of the box. This dot size is the size of the box. So that's the bottom of the box. If the bottom of the box crosses 500, then we will make sure that the speed is negative. Okay. So how do we make sure the speed is negative? We do is we do this dot speed equal to minus math dot abs of speed. Okay. So we make the speed negative in this case. And if this dot y becomes less than 0, if it reaches the top, okay, so in that case I will do this dot speed equal to mat dot abs this dot speed. Does that make sense? So if it reaches the bottom, I will turn the speed negative, so it starts going up. And if it reaches the top, I will make the speed positive so that it starts going down. Does the bouncing work? Let's see. Right? Perfect. Is all of it making sense till now? I will do is just update the code to your GitHub once, give you 2 minutes to check it out and see, check it out not as git checkout, just go and see it, okay? Just like you check out each other, right? So just check out the code and see if you understand, and if you have any doubts, then ask me. So the code is here. It would be in your demo folder, and in canvas intro, script.js is your script. So it's not a big script. So just check that out. Okay. And the HTML file really does not have anything. It just has a canvas. Okay. That's all the HTML file has. Okay. So take a look at it. And if you have any doubts, just ask me. I'll give you a couple of minutes to read that code. Then we will do other stuff with this page. Okay. The speeds, I think ideally should be more like, I don't know, 4 and 8 look better. I think otherwise it won't be challenging enough. If you want to have another enemy, we can do that as well. E2 equal to another enemy which has even faster speed, say 12, and let's say one of them is at 100, the other one is at 200, and the third one is at 300. So let's move E3 dot move as well. And yeah. Oh, did I not draw E3? I think the space is too little to actually run this. So let's do it is keep this one at 100, the other one at 250, and the final one at, I don't know, 233, and the other one at 366. Let's make some space between them. So all good. Everybody is understanding the code till now. Like, I'm not saying understanding to the level that you can close your eyes and write all of it right now, but you're able to, figure out what's happening, and given enough time and reading that code, you'll be able to reproduce this, right? Let's draw the player as well, right? So a lot of times what people do is, instead of doing it this way, people have a function called game loop. And inside the game loop function, people, write all of that stuff, right? And then they do is at the end of the game loop, we do window dot request animation frame on myself. And for the first time, I just call game loop. That also works. Okay. So you call game loop first time, it does all of these updates once itself, and then it calls window.requestAnimationFrame on game loop, which means game loop will run again. And this way also you can do it, because window.requestAnimationFrame takes a callback in its thing. So you can do it this way as well. Okay. So, okay, we should also be drawing the player. Drawbox player, right? And that's my player. So what we can do is on this canvas, we can add some events for handling the game state of the player as well. Okay. So let's do is canvas dot add event listener. So there's this function called add event listener. What it does is it listens for events, and we can have an event called mouse down. And when we have the mouse down, what we will do is, so we should also have a way to move the player. So what we'll do with the player is the player should have speed as well. Let's say I give this player a speed just to start with. Player dot speed equal to say 10, right? Player dot speed is 10, and so player will also have a move function, right? And it will also have a move function here, and this move function is going to be the player's move function is going to be this dot x plus equal to this dot speed. Okay. And this way the player would move. Okay. Okay. What is the game loop and what it is? Okay, game loop is nothing. Game loop is just a function. It's a just a name that people use for that function. So in the earlier way, we had done like a little bit of convoluted way. We had created request animation frame, and inside that we had done the recursion. So here what we have done is we create a game loop function in which we write what all things are to be happened every time the frame needs to be updated. And at the final line, what we do is we do window.requestAnimationFrame and call, don't call game loop. What we do is we pass game loop as an argument into it, because requestAnimationFrame function takes a callback function. It's a function that runs at the end of the requestAnimationFrame, right? So earlier we were doing it like we were creating a function, and then inside that function, we were writing what all we want to do here, right? So instead of doing that, we just pass the name of this our own function itself here. So at the end of running all of these things, what the game loop does is it will just request itself to be run before on the next frame update. So the next frame update is something that's dependent on how bad or how good your browser is running. So if your browser is say running at 30 fps, then the next animation frame update will come after 32 seconds milliseconds. If your frames are running at 60 fps, then the next request for animation frame will come after 16 milliseconds. So whatever is that time after that, while that game loop request will come. So in a way we are achieving recursion like this itself, and then to initiate it for the first time, we're just calling this function. Okay. Now what we want to do is we want to have this move function for the player, and with this move function for the player, we will do is we will this dot x equal to this dot speed, and let's say if I want to do player dot move. So in which case okay, something didn't work, I think. Let's see, something stopped working. Canvas is not defined. Oh, paint box. So my name of my canvas is paint box. So I'll do is paint box.add event listener. Anyway, with this code we are just going to use later. Just saying is that if I move the player, so now that's the player moving, right? I think it's a little too fast, so we can make it move at speed less than that, maybe at 5, which is fine. So there's the player moving. So what I want to do is in the player, I want to add another parameter, this dot moving equal to false initially. And in move, what I will do is if moving value is true, then I will do this. Otherwise, I will not do this. Otherwise, running move will not move the player. Okay. So you can do it two ways. You can either do it by the speed way or by this way. And what I will do is when this mouse down event happens on the paint box. So let's say console.log, mouse down, and let's see in the log what happens here. So if I click here, when I press down, mouse down event happens, and when my mouse click is removed, then the mouse up event happens. Check a look. I click here and mouse down has happened, and I'm holding my click right now. And as soon as I leave my mouse, then mouse up event happens. Mouse down, mouse up, mouse down, mouse up. Okay. So let's do something. In fact, instead of doing via moving thing, let's let this be. This is fine. This is not an issue. So when mouse down happens, we will do player dot speed equal to 5, and when mouse up happens, we will do player dot speed equal to 0. And initially we will do player dot speed at 0 only, so the player would not be moving. So if I click down, it will move, and then when it goes away, like this. Okay, so that's how we can do this. Now that's my basic stuff of my game is done. Like when I click, the speed of 5 gets added, and as long as I have it clicked, it will continue to move, right? And then it will stop moving, and we reach here. Okay. So now the fact is actually maintaining the collisions, right? And handling the game over state and everything, right? So those kind of things, how do we handle that stuff? Okay. So this will not work on mobile swipes. What will happen is on mobile, you will have to keep this place pressed. If you have it long pressed, then it will move when you remove your touch. So whenever you keep it touched, click down, then it will move, and then later on it will stop moving. right? So you can play it on mobile as well. You can actually try out how it works on mobile by going to inspector, going to the responsive tab, in touch mode, and there you will see okay, so that way you can do some mobile emulation as well. Now coming back to actually seeing if they are colliding or not or something like that. So we can have a function which checks is colliding. Okay, how do we do that? We can create a function okay, so how do we check if box 1 and box 2 have collided or not? Okay, so what we'll do is what the factor of collision is that if the collision can happen if the end of so what all things are needed for collision to happen is that there should be overlapping surface. So like for example in this case like at this point, right? So at this point when it is colliding, so we need to check if there is any overlap between the two boxes or not, right? So how do we check such a collision to be happening? If the two boxes are of similar size, then it's a little easier to, of course, calculate that. Okay. But can somebody tell me on the chat, like, how do we find out the collision? Or can somebody, like, if you want to raise, if you want to like tell it on audio, you can raise your hand as well, and I can just allow speak as well. But if you can tell it on chat itself. Anybody wants to have a try? Like, how do we find using X, Y, and the size of the boxes whether the two have collided or not? Or I would say do one thing. I am just writing this function is collided box 1, box 2, and we'll do something very interesting. So we'll check here. So we will have a game state kind of thing here. We can do things like this. If is collided, E1 player or is collided E2 player, or is collided E3 player, then what you can do is you can do a window.alert game over, and you can keep some game state variable here you can set game on to false and write this game on equal to false. And in this game loop function, what you can do is that if not game on, then return. So your game will end when game on becomes false. Then the next game loop, it will return, and when it will return, so the game will stop moving, it will freeze, of course, right? And if people can refresh the page, and then they can actually start playing the game. So this way you can do. And you can also do is create something called you know very interesting little hack to make the game difficult is one thing you can do. We can make a value here. Let player speed equal to, say, 5 I take, and I have this constant value of let player speed equal to 5, like this. And or you can do is you can do a yeah. So what we do is whenever I click player.speed, I turn it into player speed, and otherwise I turn it into 0. Okay. What we can do is we can run a set interval every 1 second. Every 2 seconds, let's say. What we'll do is we will take player speed and player speed equal to. So what is the value of math.random in our page? It is this, math.random gives you a value from 0 to 1. It's a decimal value. So if I take math.random and multiply it by say 10, I will get some value like this. So what we can do is player speed equal to %, math.random into 10. So every 2 seconds, my player speed will also change. So this way what will happen is, like, now it's running at this speed. Sorry. All right. Why does this box just go away from the screen? We will have to take a look at that as well. Maybe we can change it between the values of 5 and 15. So we can do 5 plus yeah. So again, we have a problem. We have some debugging problem here. It's going away from my screen at certain points, and why is that happening? We can do is at mouse down, we can just do console.log print the player speed value and see why that is happening, right? Player speed is coming out to be not a number. Okay, so it is coming out to be not a number because what I've done is I've done a mistake. If you write this code, you will see you will get a not a number itself. That's because math.random, I have to call it, which I forgot doing it. Again, debugging is not hard. You just wherever you are looking for values to change, print the value there and see why it has not changed. Okay, so that's the most important thing. So there we go. And now we should see. So this can make the game a little more harder. Okay. And if you want the box to, also change the Y of the box certain times as well, that also you can do. So every time this will happen, and player.y equal to 100 plus math.random 300. So it will change anywhere between these values as well. Okay, so every 2 seconds the position of the box keeps changing. Okay, which of course can be a difficult thing to handle in this particular scenario. So the Y of the box will keep changing like that, and then it becomes difficult to of course play in that sense. Okay, so oh, sorry, again, my bad, into 300 like this. Yeah. Yeah. So every 2 seconds, the position of where the box is, it can change. You can do stuff like that, because then it will become even more difficult for it to reach the end goal here or something like that. Okay, so a lot of other interesting things you can keep doing. I would like you guys to fill this thing yourself. And whoever sends me the code of his collided, and so what you have to do is fill the code for his collided, write what is going to be the code for his collided, and then run your game, and take a small screen recording of the game running, and you have to email me to Arnav at codingblocks.com. That's my email ID. If somebody does not have it, it's Arnav at codingblocks.com. In the subject, you write, demo session 4, and first person to have written it correctly and showing the game working I would send them across a goodie bag, a coding blocks bag, and some t-shirts, and whatever stuff we have. Maybe we might have a cup or a pen or whatever goodies we have in stock right now. We would send you a goodie bag to you, whoever can finish the is collided function the first, and make a video of it and send across to me. Okay, cool. I think you learned something good doing this. You can keep extending the game, have fun with it. And yes, there would be a recording of this video on YouTube available. Okay, so thank you guys again for attending this session. Hope you had fun. Hope you learned something new. And if you want to take part in the course, drop a mail to support or to me. And there is cast and APAD happening on the 2nd of this a month, 2 days later. So you want to look for some scholarships. If you want to join this course, you can do that. Okay. Meet all of you guys at the next demo session. We do have a couple more demo sessions before we start with the course. Okay. So stay safe, stay at home, and have a good night. Okay. Bye, guys. So all the details about the demo sessions and all is available at cb.lk, codingblocks.com/live classes. And you can register for demo sessions by clicking there. Okay. And all the course lectures that are going to be there in the course, there's the Node.js one. You can see the description, and you can see all content that's going to be covered, and you can register for the demo class there. Okay. We have 2 more demo classes before our actual sessions begin. Okay. So have a nice day. Thank you for attending.